All right, so this is a video showing you all how to sample using Excel. So what we're going to do is we're going to use the variable age to show you this process. So we're going to come over, find the variable age. So here's the variable age. Okay, I'm going to copy this. I'm going to open up a new sheet. Okay, then I'm going to just go ahead and put that there. And so I have the variable age, and what I want to do, so I know I have 1,500 respondents in the data set. So what I want to do is I want to sample maybe 10% of the data set. And why would you want to sample within the general social survey? Why would you want to sample a sample? Well, the reason why you might want to sample a sample is to do preliminary analysis. So you don't have to look at the entire data set. You might want to run some preliminary analysis looking at a small section of the sample to see whether or not there appears to be a relationship between whatever it is that you're looking at. Okay. So how do you go about doing this? Okay, so what we're going to do here is I'm going to on I'm going to put random. I'm just going to name this random 10%. And then you could put, an N of 150 if you want to. I'm just letting myself know that this is a random 10% sample. So I'm going to do a random sample of 10% of the 1,500. Now I know that 10% of 1,500 is 150, but if you don't know how to actually get the N, the number that you need, so what you would do is you would use a calculator, and then you would take the N, which we know the sample that we have in our data set is 1,500, and then we would multiply that by 0.10, which we know is the proportional equivalent of 10%, and then you would get 150. And you can do this for any percentage. Let's just say I wanted 25% of the data set. So I would do 1,500 times 1,500 times 0.25, and then that would give me, need to clear it out, 1,500 times 0.25, and that is going to give me 375. So that's the number that I'm looking for. So that's how you go about getting the N. Okay, so if I wanted to sample this data set of 1,500 respondents, I need to copy all 1,500 respondents. I don't want to copy the cell that says age because that's not an actual respondent. That's just the label. So I have this. Now what I'm going to do is I'm going to come over here and I'm going to go to data. So data, I'm going to go to data analysis, and I'm going to come down here to sampling. Click on sampling. I'm going to press OK. Now my input is, actually you're going to have to go back and do this. Okay, so I'm going to have to input all of these 1,500 observations. So that'll be my input. And I am going to use a random sampling method. So you see periodic. Periodic is kind of like a systematic sample that we also learned about in lecture, but we want to do a random sample. So random sample, and I want an N of 150, so I'm going to put 150 here. And then I'm going to put the output range is just where I'm going to actually get that sample, so I'm just going to put that output range is just going to be here. Right below this random sample of 10%. And then I'm going to press OK. And then it should have sampled 150 respondents randomly. It did, because it gave me 151 minus the one which is just the label. So what I can do now is actually I can go about checking the mean standard deviation for my sample of 10% in relation to the entire population, just to show some of the characteristics of sampling. So the way I would go about looking at the mean standard deviation, stuff like that, is I'd copy all of this, go to data analysis, click on descriptive statistics. I keep doing this before. So I need to copy all these respondents. So I got all these respondents. That'll be my input. And then of course I want the summary statistics. And so this provides me the mean, the standard deviation, the standard error of the mean, the median, the mode. So we see the mean here, 48.86, standard deviation, 18.19. Now I could also do this. So this is the descriptive statistics for the whole, right? And I can also create the descriptive statistics for just this 10% sample. So I come back over here to data analysis, do descriptive statistics. So instead of all that section, I'm just going to do this section here. Just these 150 respondents. So that's who I have in there. Then my output range, I'm just going to have it be right below it. So this is the descriptive statistics for the second sample, for the actual sample, the 10% sample. This is the descriptive statistics for the whole 1,500 respondents. So as you can see, the actual mean is pretty close to the mean of the full. I'm just going to label this descriptive. That's full sample. This would be descriptive statistics for 10% sample. Okay, so as we can see, the median shifted a little bit, the mode shifted, the mean is pretty close, and the standard deviation is actually pretty close to for the full sample as well. Now we could also do this if we wanted 25% of the sample, right? So what would you do to get the N for 25% sample? You take 1,500, you multiply it by 0.25, and you should get 375. So if I wanted to do this, let's just say I wanted to sample again. And I want to get, I want to get the whole 1,500 respondents, but then I want to sample, just 25% of them. So I wouldn't do 150, I would want to do 375. And then for the output range, just say I want to do it over here. So I have the sample of 175, so that'll be my random sample, 25%. That's my random sample of 10%. Then what I can also do is create descriptive statistics for this as well. For this data set. Instead of being here, I want my input range to be here. So I get all 375 of these respondents. And I'm going to put my output range somewhere right here. Okay, so this is the descriptive statistics for the full sample. This is the descriptive statistics for the 10% sample. And then this is the descriptive statistics for the 25% sample. Okay, so we can see that here the mean is actually a little bit lower than what you would have for the full sample. The actual mean for the 10% sample is actually closer. And I know that might be counterintuitive. You might say, well, if the number is higher, if the N is higher, shouldn't the mean be closer? Technically, that's typically the way it works, but it doesn't always work like that because sample means always fluctuate around the population parameters. Sometimes they're a little bit higher, sometimes they're a little bit lower, sometimes they're closer, sometimes they're far away. So it doesn't completely work like this, and this was a random sample. Okay. If you look at the standard deviation, it's actually pretty close to the full sample. One thing that's important to note about the 10% sample versus the 25% sample is the standard error. So if you remember, the standard error describes how much dispersion you're going to see in the sampling distribution. And as you can see, as the sample increases, so as your N increases, the standard error, the mean decreases. We discussed that in lecture. So as you can see, the standard error for a 10% sample is 1.54. And then the standard error for a 25 for this sample, which is getting 25% of the sample of the 1500, it gives you standard error 0.92, which is actually smaller. So when our N increased, our standard error is smaller. We're having less dispersion and less variation in the sampling distribution. So this is how you sample using Excel.